Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Today, I'm going to present my research progress for this semester. My research entitled Optimum Load Control Strategy Using Improved KNX Building Automation System for Educational Building. My name is Sharina binti Safi'i. I'm from program EE950. Under supervision of Associate Professor in Senior Technologies Dr. Nafri Janita Dahlan, Associate Professor in Senior Dr. Rosita Jailani, and Dr. Muhammad Fani Sulaiman. Currently, I'm in semester 7. Now let's see the executive summary of this research. Most of the research on building automation system mainly focuses on remote surveillance and control of home equipment rather than concentrating on issues of efficient energy usage in commercial buildings such as educational building. The main objective of this study is to optimize the load control strategy of KNX BAS using a meta-heuristic optimization algorithm for the educational building. This study begins with developing a baseline energy model of an educational building. Then, KNX-BES is installed as a retrofit measure to reduce energy consumption by controlling the selected loads in the building, such as lighting, fan, and air conditioning. Particle swarm optimization and evolutionary particle swarm optimization algorithms are developed and integrated with KNX software and hardware to optimally determine the load management control strategy at minimum energy use and cost. The analysis is carried out to compare the energy performance of the existing system KNX-BAS, PSO-KNX-BAS, and EPSO-KNX-BAS on optimal load control strategies, energy use, cost, and savings. The energy saving will be quantified using a measurement and verification approach following the International Measurement and Verification Performance (IPMVP) protocol. This study's contribution is integrating new meta-heuristic optimization algorithm with BAS to determine optimum load management control strategy in the academic building and further expansion for artificial intelligence study with a real-time input from KNX BAS. There are 4 problem statements for this study. The first is electricity bill of KKKL, which is College Community Kolangan, was increased in 2019. It is important to understand the energy consumption pattern. The accurate data from end-user groups often unavailable, hence causes difficulty to perform energy benchmarking and developing energy-saving strategies. Problem statement number 2 is non-efficient use of energy due to non-optimal management response strategies. The third problem statement is BAS device setting completed at the installation time by a qualified person and only can be resetting by that competent person. This became a major problem in rapidly changing environment. The last problem statement is BAS was programmed at certain setting point and does not meet the comfort level of occupant during certain climate. Limited researches from integrating AI with BAS, specifically KNX, to optimally control the load. Users are less aware and usually neglect the electricity consumed. The first objective for this research is to determine baseline energy consumption and its relevant variables and educational building with KNX-BAS retrofit measures. Objective number 2 is to develop an optimum load control strategy to minimize the energy used while meeting the occupant's comfort level using meta-heuristic optimization technique PSO and EPSO integrating with KNX-BAS for static and dynamic load. The last objective is to validate and evaluate the performance of KNX-BES integration with PSO and EPSO in terms of energy saving and cost using measurement and verification approach. Now let's see the scope and limitation for this research. For the scope for objective number 1, consumption data for pre-retrofit period was collected from TE block. Number 2 is baseline energy was constructed based on the usage pattern. And the last one is retrofit activities was involved electrical wiring system at laboratories in TE block using KNX-BES. However, the limitation is consumption data from TE block with KNX-BES. Retrofit involved lighting and air conditioning circuit and only using KNX-BES system. For scope and limitation for objective number 2. For the scope, PSO and EPSO optimization algorithm model development for static and non-static load. PSO and EPSO optimization algorithm model evaluation. The last scope is PSO EPSO will be integrated with KNX-BES. And the limitation are focus on static and non-static load. Excluded plug circuit. The last objective. The scope are comparative study for the optimum saving between PSO KNX-BES and EPSO KNX-BES. Number 2, quantify energy and cost saving using measurement and verification approach. The last scope is analysis on the test data comprising of consumption data from before and after integration and PSO and EPSO. The last limitation is saving calculation not consider plug circuit because the circuit is not included for retrofit activities. This is the research framework. We start with KNX building automation system retrofit activity, and then the system will be integrated with PSO and EPSO. The last one is the output is the load control strategy. Using that improve KNX building automation system integrated with PSO and EPSO. This is the IPMVP protocol that used to quantify energy saving in this research. For literature review, there are 6 gaps identified during the literature review process. The first gap is it is important to modify the baseline or actual performance to account for variation in weather patterns and adjustment in the context of the building before and after the refurbishment. This gap is aligned with problem statement number 1 and research objective number 1. For gap number 2, the energy saving is often inconsistent over time due to non-optimal energy management and demand response strategy. This gap is aligned with problem statement number 2 and research objective number 1. The third gap found is the integration connects with the new algorithm lead to a new solution for the configuration issues that only a qualified person that can adjust the configuration of the devices in concern that rise up recently. This gap is aligned with problem statement number 3 and aligned with objective number 2 and number 3. The fourth gap is due to variation between the occupant, which is metabolism, activities, clauses, etc. It is not possible to maintain the same degree of comfort for all occupants. This gap is aligned with problem statement number 3 and objective number 2 and number 3. The fifth gap is BEPG between forecast and real consumption triggered significant issues in building energy, supply and demand management so that researchers around the world have been attracting growing interest. This gap is aligned with problem statement number 4 and objective research number 3. The last gap identified during literature review process is none of studies use PSO and EPSO in BAS narrowing to KNX scope. This gap align with problem statement number 3, problem statement number 4, objective number 2, and number 3. For the overall methodology, the flow starts with theoretical study, data collection for objective number 1, development of load control optimization in objective number 3. The last one is comparative study, optimum energy saving, integration of PSO, KNX BAS, and EPSO KNX BAS. For the first objective is to determine baseline energy consumption and its relevant variables in the education building with KNX BAS retrofit measure. The variables considered is, the first is usage pattern, number 2 is day, number 3 time, number 4 is date, number of occupant, timetable, and weather, which is temperature. This is the layout of electrical technology block in KKKL, where the retrofit project was carried out. This is the first location of the retrofit project, which is at Magma Technology Electric, MTE. The installation involved is the installation of movement sensor, touchscreen with IoT, and DB, KNX DB for the actuators. Okay, this is the second location of retrofit project, which is at Magma Electronic or MEE. The installation is involved with KNX switch actuators and also sensor. This ETS6 software is the software to program the parameter setting of the KNX system regarding to the occupant needs. This is the appearance of the software. For the first objective, data was collected for 2 locations of retrofit project was done. The first is MTE, the second is MEE. This is the baseline data for MTE. This is the baseline regression analysis for MTE. This is the result of post-retrofit data of MTE. From the analysis of post-retrofit data of MTE, the energy saving was quantified about 30.83% of consumption. This is the baseline data of MEE. This is the regression analysis of baseline data of MEE. This is the post-retrofit data of MEE. From the analysis of post-retrofit data of MEE, the energy saving quantified it's about 30.83% of energy consumption. The second objective of this research is about development of load control optimization, which is the first is PSO KNX BAS and the second one is EPSO KNX BAS. There are 2 main parts of integration, PSO KNX BAS and EPSO KNX BAS. The first one is KNX IoT, the second one is Python KNX. This is the photo of KNX IoT training kit. This is the touch panel or touch server used for this KNX IoT. This is the specification of the touch panel. This is the display of the touch panel of the program. This is the software to program the touch panel setting. This is the display after the program was deployed to the touch panel. This is the part of Python Connect's coding. This is Connect's control algorithm for lighting, and this is for air conditioning. So this research is still pending at objective number 2 for the integration process. It's still about coding the Python algorithm. Okay. However, look at the third objective of this research is to validate and evaluate the performance of the KNX-BS integration with PSO and EPSO in terms of energy saving and cost using measurement and verification approach. This is the status of data collection for this research. For the objective number 1, the data collection was done for baseline and retrofit data. For objective number 2 is still pending due to progress of integration between PSO KNX BAS and also EPSO KNX BAS. Same goes to objective number 3, still pending. For the status of data analysis, for the objective number 1 was done because the data collection was completed. While for objective number 2 and number 3 still pending due to the objective did not complete yet. This is the list of publication. For the first publication is a review of the KNX system in addressing climate change and energy efficiency. The publication was submitted. Number 2 is quantify energy saving for retrofit KNX building automation system at KKKL. Still in the writing process. The last one is application of machine learning in building automation system, which is a thematic literature review. Still in the writing process. This is the status of thesis writing. There are 6 chapters. The first introduction is about 90% of writing. For chapter number 2 is about 80% of writing. Chapter number 3 is about 70% of writing. Chapter number 4 is about 10% of writing. Chapter number 5 is about 5% of writing. And the conclusion is about 5% of writing. For the references, is also about 20% of writing. This is the planning for my study. Still about literature review process. The data collection still rely on the integration process. Then analysis report still will be carried out until end of this year. Also, this is writing for seminar or workshop related to PhD, like thesis bootcamp. Will join on next year, and then I plan to submit the notice of intention on January 2024, and then Viva will be held on May 2024, and then also thesis submission on August 2024, inshallah. So what's next for research activity in order to complete my PhD is about optimization modeling, integration of Python and KNX-BS. Okay, the data collection should be accelerated right after the integration done, and then data analysis, the publication, and the last one is thesis writing. I really hope can finish my studies soon. Please pray for me, and thank you.